Hello, welcome back to Blender Sushi Live Noding. In this video, I'm going to share with you a little study that I did. Basically, what I did here is I have a torus objects, and then I'm using Sverchok, and I'm getting the bounding box of these objects, which is this one represented by these yellow outlines, and then I would like to fit the vector P nodes, which is like a 3D volume um, grid, into the bounding box of the torus. So I got it right here, and then it's actually quite a complete setup. So I can rotate the torus, I can scale it in any directions, and yeah, the points basically will scatter um, within the bounding box of the torus. So that's the main idea, and this is how I set it up. It's actually quite simple. It's not like really complex, but I think this is quite nice. So especially for beginners, so I really want to take you through the process. So I start with a torus right here, which is real objects in Blender. It's not made using nodes. Of course, you can generate the torus using Sverchok as well, but in this case, this is just like a real objects in 3D view. So I source the torus using the objects in, and first thing I do is actually this vertices goes into the bounding box, and the bounding box node will give you this yellow bounding box, of course, but by default you need to kind of apply the transformation of these objects in order for the bounding box to kind of fit inside the objects, because the object is actually transforming. So that's why I'm using matrix apply. So this one is just one process, and the next one, I know the fact that this vector P field will kind of make like a 3D grid within the boundary of this size X, size Y, and size Z. And knowing that, I really need to just pass in the dimensions, the dimension XYZ of the bounding box, right? Currently, the bounding box node doesn't have the output of dx, dy, dz, or the width, the height, and the depth. So I really want that. So here if you look at the index, look at this corner, it says index 0, right? If we measure the distance between index 0 point and index 1 point, we're gonna get the width, I guess. If we measure 0 and 2, index number 2 points, we're gonna get the depth, and then the height will be between 0 and 4. So that's exactly what's going on here. I'm actually just grab the output of this bounding box vertices and kind of measure it. So I'm listing the item between, you see, like index 0 and 1, you're gonna get basically the dx, and then you get the dz, and then the dy. Here I'm really just using the list item and get the index, and then I'm measuring the distance between those 2 points. So I get the dx, dy, dz. I can just plug it in into the vector P, and as a result, I'm getting these points. I can easily kind of like make a grid of points based on the bounding box of these objects. So yeah, that's really pretty much what I want to show you. If I'm not wrong, if you have like a multiple objects all with a different dimension, let me try doing that. If I grab these 2 objects and just source it right here, we're gonna get the result, unless I'm doing it wrong. So this one doesn't seem to confirm. Maybe I thought this will actually work, but maybe I was wrong. So this one give you the bounding box. Join, maybe I turn off join. Okay, I turn off join, so I have two vertices here, goes inside this guy, distance 2. Maybe the actual vector p field itself is not vectorized. So anyhow, we get the bounding box, and we can kind of pick between these two. Yeah, that's pretty interesting, but something to keep in mind. Anyway, it works for single objects. And then this part where I have this dx, dy, dz, that's actually can be simplified using a script node. For example, I made this little script node. I call it BBox, bounding box, dx, dy, dz. So I open it. So this is how script node looks like. So basically I have this distance function, so simulating this node, and this is more like a quick one that I did earlier. So you can use script node lite, grab the Python code, make the nodes, and we simply, instead of having all this how many, 1 2 3 4 5 6 7 6 plus 3 9 nodes, we can simply pass in these points there and pipe it in. I think it should work. So this one also I didn't vectorize it, so I have two datas coming in, only one data coming out, but it should basically still work, I believe. So vector p field, maybe I'll just grab one of them and reload. So yeah, this guy still works, and I can specify how many points we want. 10 by 10 by 10, 1000 points here we have, and 1000 points we can randomize it if you like. It's gonna spread out. We can also, if we want to get the points inside, you already know how to do it. Points inside mesh. So this is bunch of points, 1000 points within the bounding box of this torus, and all I need to do is to pipe in the torus data. So the torus data goes in there. Let me check. So this is the points. I need to be careful here because I need to apply something first. Yeah, I think I need to apply this points and this matrix, and if I'm doing it correctly, this is the new points with the matrix apply. So this points goes into the points, and we just need to pipe in the torus vertices and faces. You go back in there. We're gonna save this real quick, and the output should be bunch of points. Oops, bunch of points inside the torus, if everything is correct. You're probably still calculating or something. Sometimes this guy needs some kind of nudging. Vertices, faces, maybe I need to apply the matrix. Yeah, this is slight little gotcha there. We need to apply the matrix and then pipe it in the torus. Okay, now we got the points. Save, and we can see randomize the points. So we kind of get like a scattering of points inside the torus, more or less. That's kind of nice. And if you want to have like a box inside it, it's kind of interesting. Actually, we can easily kind of generate like a cubes inside the points. seems to be frozen or something. Vertices goes into matrix. Okay, cool. So this is like a kind of like a cube bricks inside the torus. It's maybe it's better if the torus is actually straight, or I need to rotate the cube, but this is a start anyway. So I'm gonna reset the rotations of the torus. I can still scale it, and let's refresh. So now we have a bunch of box inside the torus, kind of like a remesh modifier, kind of. And let's increase the number of box. So it's like the Minecrafting or like a Lego, but you kind of have proper boxes for each points being generated inside the torus. Yeah, so there you go. It's pretty interesting, and you can randomize it, kind of scattering the points a little bit so it's more random. Yeah, something like that. So there you go. That's how we can kind of fit the points, the 3D voxel points, get into the boundings of an object, and then we can instance some objects using Sverchok. So yeah, it's a lot of concepts here. I think they're not overly complicated, but I think it's really nice to be able to do this in Blender, and really everything is visualized really nicely. Yeah, of course you can do this using particles, but then with this you can really customize everything, and every step is very clear. With particles it's like kind of like a shortcut, right? Particles, you know, you just create particles and then scatter particles inside the volume, and you do that like within this frameworks or Blender particles. But sometimes you want to do it yourself from scratch, and this is kind of how you do it. Maybe you make your own particle system at some point. Of course you can. It's not impossible. Yeah, so that's pretty much it. Hopefully you find this useful. Let me know what you think. Any feedbacks or any question, I'll try to answer it. Thanks again for tuning in. I'll see you in the next video.